We'll proceed in vector summation integral calculus. Okay, so we have started discussion in vector summation and integral calculus. Can we solve our problem dividing problem part-wise into n number of parts? Can my problem Can I divide my problem into n different parts and solve part by part? Then at the end, we sum it. When we sum it, then if we think it is not very nice, then we make n tends to infinity. And then we see if result is alright. If result is alright. Okay. In that manner, we are doing computation for the banking system. Banking system is a bank is giving there are many ways banking system works. I can deposit money in the bank, and where is the recurring recurring term deposit is there, recurring interest is there. I can deposit money in bank. It is typically called fixed deposit. If I deposit money in a bank in a fixed deposit, and then I give some amount in the fixed deposit, then amount would start giving interest. And after a duration, I'll receive one interest. And after that duration, typically 1 year. After 1 year, my principal amount and interest will become principal amount, and then interest will be calculated based upon the new amount. And then after 2 years, whatever is the principal amount and interest amount altogether, they will become principal amount. What is the interest rate we are talking? Interest rate is C%. C can be 5%, 6%, 7%, 8%. This is what I have seen in the bank. Maximum 9% I believe, but it is not practical. Typically 5, 6, 7, 8% we have seen in the bank as far as the fixed deposit is concerned. If person is depositing $100 or 100 rupees, 100 yuan or 100 ruble, 100 pound or euro, okay, in the bank, and then he would see if it is with 5% interest, C equal to 5%. 5% means 5 by 100. If you deposit $100, you will get $5 as interest. If the recurrence is happening year by year, then at the end of 1 year, someone would get 1 plus C into the principal amount, or principal amount plus the interest that is calculated on top of principal amount. If principal amount is 100 into C by 100, that is C. Okay, so net amount will be 100 plus 100 into C. C, whatever C is 5 by 100 into C. That will be 100 and in bracket 1 plus C. At the end of 2 years, it will be 100 and in bracket 1 plus C, again in bracket 1 plus C. At the end of 3 years, you would get 100 and in bracket 1 plus C, in bracket 1 plus C, and then multiplied by again in bracket 1 plus C. If I say 1 plus C is a constant, 1 plus C is A, 1 plus C equal to A, then it is 100, whatever the principal amount. What is 100? 100 is, if I say the amount in my fixed deposit is Y at any time T, where T is in years, Y, and in bracket small t bracket close, Y. The amount in my fixed deposit at any time T is YT. YT equal to Y0. What was the amount I had deposited at the beginning when time is 0? 0th year at the beginning, what is the amount I had deposited in the account? That is Y0 multiplied by A into A into A into A for T. Yes, A to the power T. YT, Y the money in my account or anyone's account. I don't have any fixed, I don't have money at all. What is fixed deposit? I'll do. Anyway, so YT equal to Y0 into A to the power T. That is the amount someone can expect after T year, where Y0 is the initial amount. Now we have said there is the extra. Whatever we have talked in calculus for 1 year or 1.5 year, 1 year, everything we are going to show on electronic circuit. Okay, that is the greatness of calculus. Whatever we have talked, integration, integration, differentiation, and then we will talk differential equation, and in between we are bringing artificial intelligence scenario also, orthogonal components, multiple feature, and so many things. Whatever mathematics we are talking, mathematics covers artificial intelligence also, vectors, everything. Everything we will show on a hardware circuit. If I say everything I'll show on a software circuit, then people will say, same thing, whatever you're talking, you're writing in a program, and then it is executing. What is greatness there? Nothing. Okay, dy by dx is equal to this. You brought it with some formula. Whatever you are talking in, you are speaking or you're writing on a paper. Same thing you did through the programming way. So I'm not interested in your software. There is nothing difference in your writings and your software. Only thing you're writing on paper, they are writing on a memory chip. What is difference there? No difference. Okay. So whatever we have talked in mathematics, everything we will run it on electronic circuit. Electronic circuit means capacitor, inductor, resistor, transistor, or other thing who show the variable resistance. Anyway, resistor does not show variable resistance. But there are n number of devices, they show variable resistance. If you grow in voltage, then current will not grow linearly. If I grow voltage across resistor, current will grow linearly. So resistance show linear equation. Whereas if I increase voltage across capacitor, then current will not grow linearly. If I grow voltage across transistor, if I grow voltage across diode, if I grow voltage across inductor, if I grow voltage across any other device that is not linear like resistor, then there will be non-linear curve I would expect. And there, when there is a non-linearity, there is not a division. Linear equation have multiplication and division as far as mathematics is concerned. Non-linear, non-linear equation, they have differentiation and integration. Why it is? Because every moment line is changing. If line is a straight line, it can be flat line or a slant line. If it is a straight line, then calculus is not required at all. Division will work, multiplication will work. But instead of a straight line, if I have this x-axis, if I have this x-axis and this is a straight line, then calculus is not required. Because if I talk about different division, then everywhere line is going in one direction. Any moment if I see what is the direction of the line, all moment have same direction. Means y by x is constant. But if I talk about a curved line, any moment if I see line is any moment if I see line is changing its direction. So every moment delta y by delta x, delta y by delta x, delta y by delta x will be different. That is differentiation. So differentiation dy by dx or delta y by delta x tends to 0. That will be different. Similarly, it will work for the curve integral also. So the any electronic component which is showing non-linear functionality, like diode, it is showing non-linear functionality. If I push voltage across the diode, then current will not be there. Okay, after some time, all of a sudden current will start emerging. Okay, and then it will make a very some curve that will not be that will not be linear. There calculus comes into the picture because there won't be y by x, there won't be current by voltage, di by d, there will be di by dv. Okay, if I take inductor, if I place voltage across inductor, there won't be any current at all, the way it is in diode. But if I just put place voltage across inductor, then there won't be any current. But I'll just leave it as it is. Then slowly current will start increasing, and then it will reach its peak. If I keep voltage across diode, current won't be there and current will never be there. Then I have to keep increasing the voltage. Everyone has different characteristics. Similar thing can be seen in the capacitor also. And transistor is nothing but dual diode only. I want to say dual diode, two junction diode. If there are two junction, then there are three arena. where I can place voltage differences. If this is diode, then there are two arena where I can place the voltage. If it is triode, I mean transistor, two junctions are there, then I have three area where I can place the potential difference. And then how it behaves? Certainly it will behave non-linear only because at the base it is diode only. Okay, but the way we, if people are watching our video, then prior we talked about the calculating the four-dimensional Taylor series, four-dimensional Taylor series or three-dimensional Taylor series. There we were calculating the volume, and while calculating the volume, we saw that when x and y are in power 2, then there is a correlation factor that is x into y. Okay, if we are talking about linear, that is x and y, then there is no correlation factor between them. There is triangular volume from the x side and triangular volume from y side. We can just add it. But if it is x to the x square, means it is x square non-linear, then there is a, if it is non-linear, then there is a correlation volume comes into the picture. And correlation volume, it grows only. So if people watch, people can watch Taylor series proof that we have given through the area calculation and volume calculation. So here also, if we have a dual diode, a two junction diode, then certainly there will be correlation. What is difference between a diode, a single junction diode and two junction diode? Is it same? Certainly not. One is, if I consider in linear fashion, one is x to the power 1 and one is x to the power 2. Or one is x, then one is x and y. Two junctions are there. When there is x and y and x to power square. If I say there is only one variable is there, x. If I take power, then x square. If I take power again, then x to the power 3. If I take power again, x to the power 4. If I take dual variable x and y, and if I consider that similar model is x plus y, when it is power of 1, then it is x plus y. Simple, right? X is different, y is different, there is 1 plus. But if I take to the power 2, then x square separate, y square separate, but one correlation factor comes in, that is x into y. X to the power x plus y to the power 3, x to the power 3, y to the power 3. Very nice. Two correlation factor will come, x square y and x y square. That is what is happening in transistor, and that's why transistor is not typically dual diode. Dual diode, single variable, single junction, it behaves in a way that human brain can understand. But as we have two junction, means dual variable, multivariate calculus comes into the picture, and then it shows x for x separate behavior, for y separate behavior, but there is a mixture behavior also, and that makes transistor different. Now people are there, it is hitting their brain now. Can we go for different kind of junctions? Certainly, people have not proceeded much into it because of the complexity. Okay, people can go with the diode with triple junction, four junction, and in a very complex manner, and then you can model it into mathematics as a multivariate. Multivariate calculus still is a arena of research now. Okay, anyway, whatever we are talking about mathematics, everything we are going to put in the electronics, and in a way that people will feel that nature actually thinks in calculus way. Okay, nature is not separate from the calculus. In fact, calculus came out of the complexity of nature only. Okay, so now we are in phase of doing the complexity in the banking calculation. So banking calculation is YT, the Y the amount, if I have a fixed deposit amount after T years, how much money I have the amount when 0th year I deposited a money. Then Y as a function of T equal to Y0 at the time 0, I deposited some money into A to the power T. T is the years, A is 1 plus C. Okay, what about if external person is depositing S amount every year in my fixed deposit? I don't know. Means I don't know. It is something like without my knowledge, some well-wisher is depositing X amount of dollar in my account, fixed deposit account every year. Then we saw, this was our previous video, then we saw that it will be S into in bracket a to the power t minus 1 plus a to the power t minus 2 plus a to the power 1 plus a to the power 0. Means if someone is depositing Y0 money in the account, then after 1 year, 2 year, t year, the amount will be y0 into a to the power t. If someone is depositing s amount after 1 year, then he is getting t minus 1 year to go interest on it. Then it will be s into a to the power t minus 1. Then s amount again he is depositing at the end of 2 years. That will get 2 year less to get interest, s into a to the power t minus 2. Okay, now we were trying to calculate this formula now. What is the money that I have in my account any moment? Any moment. Yt equal to a to the power t into y0 plus s a to the power t minus 1 plus s a to the power t minus 2 plus s a to the power t minus 3 plus s a to the power a to the power s a to the power t minus 1 s a to the power t minus 2 plus s a to the power 0. Means there are two way money is going into the account. One way is someone depositing account at the beginning only, and then it is getting multiplied at the end. It will become y0 into a to the power t. One way is someone is depositing money, fixed amount s money, at the end of every year. So first year someone is depositing S amount, then S will become S into a to the power t minus 1, because 1 year gap is there. Here t equal to 0, y0 amount deposited. T equal to 1, S amount got deposited in the account. T equal to 2, S amount is deposited in the account, like that. So y0 is getting full t years to grow, whereas first S amount is getting t minus 1. This year is gone. What? T minus 1, in that way. Okay, if people are not following this, how this formula came, then people can go like this. If y0 is the amount, then after 1 year, y0 will become y0 into a. A is 1 plus c that we have seen. Y0 into a plus s that someone deposited externally. At the end of 2 years, y0 into a plus s into A will be the amount at the end of 2 years. Then again someone is depositing S amount, then plus S outside. At the end of 3 years, it will be y0 into A plus S, bracket close, A plus S that was deposited at the end of 2 years, full bracket close, into A plus S that someone deposited at the end of 3 years. Whole will become y0 a to the power t, or y0 a to the power 3 for 3 years if I am calculating. Y0 a to the power 3 plus sa square plus sa plus s. So it will come to the same formula, y0 a to the power t plus s, and in bracket a to the power t minus 1 plus a to the power t minus 2 plus 1. Okay. Anyway, now we saw through algebra that a to the power t minus 1 plus a to the power t minus 2 plus 1 is a to the power t, come back, minus 1 by a minus 1. A to the power t, come back, minus 1 divided by a minus 1. That is a to the power t minus 1 plus a to the power t minus 2 plus a to the power t minus 3 plus a to the power 1 plus 1. This is what is there. So net formula yt is y0 a to the power t plus s, and in bracket a to the power t minus 1 by a minus 1. Okay, now question is arising, can we bring through integral calculus a to the power t minus 1 plus a to the power t minus 2 plus a to the power t minus 3 plus 1. Can we sum it through integral calculus? Through algebra we can sum it, and through algebra only we brought s to the power t minus 1 by a minus 1, a to the power t minus 1 by a minus 1, for a to the power t minus 1 plus a to the power t minus 2 plus a to the power t minus 3 up to a to the power 1 plus a to the power 0. That is a to the power t minus 1 by a minus 1. Can we bring it through integral calculus? And we tried it. Can we bring it through integral calculus? And we tried it. What we did to calculate it through integral calculus. Now, to calculate through integral calculus, then we took as first as e to the power t minus x, another as e to the power t minus x, another as e to the power t minus x. We have summation of a to the power t minus x, 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 okay, up to t terms. Okay, but everything is same, a to the power t minus, where x will vary. But otherwise, we have repeated summation. Repeated summation means I have 5 plus 5 plus 5 plus 5 plus 5 plus 5, 5 7 times. I can rewrite as 5 7 times addition as 5 into 7. 5 into 7 can be rewritten as 5 into x, where x is 7, or 5 into dx, x is going from 0 to 7. So repeated summation can be brought to multiplication, and multiplication can be brought to integral calculus. Make sense? Okay, this way now we have a to the power t minus x plus a to the power t minus x plus a to the power t minus x plus a to the power t minus x, and it is going to a to the power t minus x. Okay, where x is varying. X starts with 1, so that it will be a to the power t minus 1, a to the power t minus 2. Now we have x-axis actually. This is x-axis, and x is starting from 1, 2, 3, 4, 5, 6, and it is going till t. Okay, at x equal to 1, I have a height of a to the power t minus x, that is a to the power t minus 1, a to the power t minus 2, a to the power t minus 3, a to the power t minus 4. At the end, a to the power t minus t. If I say x is 1 to any x, then what is repeated summation? A to the power t minus x into x. A to the power t minus x, a to the power t minus x, you sum it for x time, then it is a to the power t minus x into dx, x from 1 to t. Okay, if x is 1 to t, then how much it will be? A to the power t minus x integration will be minus a to the power t minus x by logarithmic of a. Okay, if I settle down x equal to 1 to t, then it will become a to the power t minus 1 and a to the power 0 minus outside a to the power t minus 1 minus 1 by logarithmic of a. Okay, this is what we saw. Okay, this is another thing that we brought, and with the natural addition, it is a to the power t minus 1, a to the power t, and come back minus 1 divided by a minus 1. Whereas through integration, we are getting a to the power t minus 1, come back minus 1 by logarithmic of a, natural log of a. Both can be same. Please watch our previous video. Both can be same. Only both can be same, provided we right now we have x equal to 1 to t, x equal to 1, x equal to 2. What about if I chop x equal to 1 to 2 in between into n different parts? What do you mean? Means bank is recurring the deposit every 1 month if n equal to 12. Earlier we had every year bank is recalculating its principal and interest amount. Consider that every month bank is calculating principal and interest amount. If it is C% every year, then every month it will be C by 12. Or if I say I am dividing my year into n part, then n is 12. So A will become A1 plus C by n to the power n. This is for 1 year into t. So 1 plus c by n bracket to the power n into t. Now this will come as calculation. Means we are making gaps very small. In that fashion, both should be similar if n tends to infinity. Because what we are calculating with adding all the verticals, it will for t minus 1, it will for t minus 2, it will for t minus 3. What we are trying to calculate adding the vertical. Then if I trying to calculate with integration, we are calculating actually the area. Area is integration, whereas addition of vertical gives the net calculation. So in between, if I talk about the vertical is like a staircase. First we have this big vertical, then this big vertical, then this big vertical, and this big vertical, where width is 1. Okay, and there it is missing, because if I take the area, if I calculate the vertical, okay, if I calculate the vertical, this vertical, and then if this is the graph of a to the power t minus 1 and going down like this, then we are calculating area underneath it. So if I take this at x equal to 1 and x equal to 2 like this, then actual integration area is whatever beneath this curve, and one end is x equal to 2 and one is x equal to 1. But if I go with the direct addition of the height, then it is x equal to 1, then this height will come and it will make a rectangle. Then next height will come, it will make a rectangle, next height will come. That rectangular region will be higher than this area, because at this point rectangular region will be this rectangle, whereas this point the curved area is top is this rectangle, this region, this portion will be more. That's why it is different. If we are trying in this manner, then how it will be same? If I chop in many parts, then rectangular region and this curved area region will not be very much different. And we saw it. Okay, then we divided our 1 year into n parts. Let's do, if I divide into 365 parts, then we are doing the calculation of principal and interest amount every day. In that fashion, A becomes 1 plus C by n, and top T became n into T. Then in that fashion, we saw logarithmic of A, that is 1 plus C by n if n tends to infinity. N tends to infinity, and C by n will tend to 0. In that fashion, log 1 plus x, where x tends to 0, is x only, that is C by n. And that side we have A minus 1, that is already C by n only. Now they are same. Top is here, it is a to the power t minus 1. T will be replaced by nt. A to the power nt minus 1. There is no difference between a to the power nt minus 1 and a to the power nt, n into t. If n tends to infinity, then a to the power nt minus 1 and a to the power nt, both are exactly same. If we take a small chopping anyway, do we have other mean of calculating this summation? A to the power t minus 1, a to the power t minus 2, a to the power t minus 3, this addition up to a to the power 0 by dividing problem into n different parts and solving it. Do we have? Actually, in paper it is written like this: a to the power t minus 1 plus a to the power t minus 2 plus a to the power t minus 3 plus a to the power t minus 4 plus a to the power 1 plus a to the power 0. Can you sum it? Okay, if I draw, consider this graph is called fx. This graph is called fx. What is your fx? Okay, fx is a to the power t minus x. This is my fx. Fx equal to a to the power t minus where x is going in a point manner. X is not continuous. X is 1, then x is 2, x is 3. Makes sense? I have a function over x equal to a to the power t minus x, where x is going 1, 2, 3, 4, not 1.5 or 2.5, only integer way it will go. So I would say what I want is summation x equal to 1 to t fx. This is what I want. Okay, whatsoever. I have a graph called fx, and fx is a graph like this. Okay, what I did, I divide this problem the way we said earlier also. I divide my problem a to the power t minus 1 plus a to the power t minus 2, whole problem into t different parts. One part is a to the power t minus x, another part is a to the power t minus x, whatsoever. I have a function over x that is a to the power t minus x, where x equal to 1, 2, 3, 4. I am just adding all the vertical. Okay, if I try to calculate through integral calculus, then I have to have integral calculus means function has to be continuous, not in discrete manner. If I talk about continuous function, that may not be fx, that will be something else. But what is similarity between these two? X equal to 1 to t, sigma sign x equal to 1 to t. I have divided my problem into t different parts. So dividing problem into n part and solving part by part. Here there is no vector though, that we will see later. Summation x equal to 1 to t, function over x. What is function over x? A to the power t minus x. If I do, it will give the net result what I want. Can I achieve it same thing through integration? Means integration of gx, another function. Gx dx, x is from 1 to t. Same. Here summation is from x equal to 1 to t, then integration is from 1 to t. Gx dx. Gx is different function. Gx is different function. Can we do like this? What do you want? I want in this fashion. I have fx summation. Same I want through gx as a continuous function, where fx is a discrete function. I want a gx as a continuous function, different function I want to invent, for which if I calculate the integration area from x equal to 1 to 2, gx dx, it should give same result what I am getting here. If I'm able to find out gx, then I can do gx dx integration, I'll get the result. Whatever is the question, I'll get the result through the. Then you have to find gx. Yeah, I have to find gx. How you will find gx? Now we have divided our problem into t different parts, where x is going, oh, it is like this, where x is going from x equal to 1 to x equal to 2. Let's take it is 1, it is 0, it is 1. Then I am at any point x equal to x. And then next point is x equal to x plus 1, x equal to x equal to x plus 1. And then if I go top, then it will form a rectangular region. Up. If I go, what is the area of discrete function? This is not discrete function. It looks like it. So this is wrong thing I am placing. At x equal to x, I have a point line x equal to x, and x equal to x plus 1, I have a point line. For x equal to x, what is the height of this line? Height of this line is e to the power a to the power t minus x, where t is constant I have taken. That is the height. If I talk about continuous function, if I talk about a continuous function, that x equal to x, this function is gx. It is not a to the power t minus x, something else. But if I take x equal to x and x equal to x plus 1, this is the area that it will calculate. This area should be same as what we have point at x equal to x when I talking about a discrete function. Makes sense? What we have now, a to the power t minus x plus a to the power t minus x plus a to the power t minus x, means a to the power t minus 1 plus a to the power t minus 2. Consider I am at a point where a to the power t minus x is the height. That height should be matched to the area between x and x plus 1 if I am talking about integral calculus. Integral calculus is repeated summation of sub area. If I say gx dx, g is a function, g and in bracket x, gx dx, x is from 1 to x, dx dx, x is from 1 to 2, 1 to t. If that is the case, then if this graph is gx, then it will x equal to 1 to 2, it will calculate the area underneath. That is same as summation x equal to 1 to t, gx delta x, if I say summation I equal to 1 to t, then gx, x belongs to the ith section, delta xi, or x equal to 1 to t, gx into delta of delta. Delta belongs to the any x section, any section. I have divided into t section. Means integration is a repeated summation of sub area. If I add all the sub area under a curve, it will give the full area. So right now I have addition of discrete quantity, a to the power t minus 1, a to the power t minus 2. If I trying to get result through integration, I have to find one function gx through which if I do repeated summation of area, then that is gx dx, that is full area. Means if I have this function as gx, I'm not sure gx would look like this or not, but fx looks like this. If this is gx, then at x equal to x, this is the line. At x equal to x plus 1, this is the line. The area between x equal to x and x plus 1 is this area. This area should be exactly same as in fx, whatever I had the height at x equal to x, that is a to the power t minus x. A to the power t minus x should be exactly same as gx dx from x equal to x to x equal to x plus 1. Okay, we will proceed on this. Let's take a simple example. Consider that I have to add 1 to t, 0 to t, 0 plus 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus t. There are discrete numbers are there at 0. Okay, 0 plus, I'm sorry. I believe I can make it even simpler. I have a repeated number. I have a number. I have when x equal to 0, then I have a number called 5. When x equal to 1, I have a number called 5. When x equal to 2, I have a number called 5. Okay, I believe it is alright. When x equal to 0, then I have a vertical called 5. When x equal to 1, I have a vertical called 5. When x equal to 2, I have a vertical called, I will make even simple. When x equal to 1, I have a vertical called 5. When x equal to 2, I have a vertical called 5. When x equal to 3, I have a vertical called 5. Now tell me what is the addition. Then 5 plus 5 plus 5, that is the addition. What is your function? Function is 5, not 5x, 5. You take any x, the height will be 5 only. What is your function? Function is 5 only. Okay, what you want? I want summation x equal to 1 to 3 5 of 5, or function fx. There is a function called fx, and fx will be added 3 times. Summation x equal to 1 to 3, where fx is 5. So 5 plus 5 plus 5, 15. Can you compute it through integral calculus? Okay, how I can compute it through integral calculus? If it is 5, fx equal to 5, I want it through gx. Gx is going from 1 to 3. 1 dx is going from 1 to 3. Okay, what is gx? Gx dx. What is gx? Fx equal to gx dx. Then gx equal to dfxy by dx. Makes sense? Fx equal to gx dx in normal terminology. Actually, fx equal to gx dx. Fx at x equal to gx dx from x equal to x plus 1. That section where x equal to x and x equal to x plus 1. Whatever the area that is being calculated through integration, that area should match the point mass height in the discrete manner. Okay, so fx at x equal to x should be same as integration x equal to x plus 1 gx dx. These are our mean. If I leave the limit, then gx dx equal to fx, dx equal to dfxy by dx, that is 0, because fx is 5, constant, it is 0. I can say 0 dx, it will not work. Okay, what I need to do here? What is your fx? What is your fx? Someone would ask, what is your fx? Fx is 5, but here gx is 0. So 0 dx is 0, 1, and you are not getting anything, but this side people are getting something. Means now I have to readjust. What you have to readjust? Yeah, if it was 5, then I took at a 0. Means it should, I have to add by 5. Then only it will come near to each other. If I did integration of 0 dx from x is 1 to 3 or 0 to 3, net is 0, where it should come as 5. Here it is 5 at any moment. Then I said, oh, I made a mistake. Looks like I took 0. Let's readjust it. What is the difference? 5 is the difference. Let's add by 5. Now try again. 5 dx. 5 dx. Now try 5 dx from x equal to 1 to 3. Then it will be 5 into 3 minus 5 into 1, 10. So I have to readjust the limit 0 to 3. Yeah, understood. So function is 5. For a discrete function 5, the analogous function is also 5. Okay, what I am trying to say, if I take 5 dx, integration will be 5x. From x to x plus 1, that will be 5 into x plus 1, 5x plus 5, minus 5x, that will be 5. So end result for the 5 as continuous function, gx, the end result with x to x plus 1 is coming as 5 only. This is 5 here also, same. Oh, I found, Eureka, I found the gx as 5. If discrete function is 5, then continuous is also 5. Now, I can do any summation, 5 plus 5 plus 5 plus 5, 10 times. Okay, 5 dx, 0 to 10. Okay, whatever you say, I can find through integral calculus. Okay, try now. Okay, I have a function called fx equal to x, where x varying with the 1, 2, 3, 4, 0, 1, 2, 3, 4, not in a continuous manner. If if this is if this is x-axis, I have x equal to 0, and equation is fx equal to x, means here the height is 0. At x equal to 1, height is 1, x equal to 2, height is 2, x equal to 3, height is 3, x equal to 4, height is 4, x equal to 5, height is 5. Okay, now you tell me the addition. 0 plus 1 plus 2 plus 3 plus 4 plus 5 plus. Function is fx, but x will go 1, 2, 3, 4. It is not continuous function. It is a slant line, but it is not continuous function. We have to do sampling at x equal to 1, 2, 3, 0, 1, 2, 3, 4 only. Not right. Okay, you have x, right? So at x equal to x, height will be x. That height should match with the sub area in integral calculus. If I take a straight line, if this is x-axis, if I take a straight line like this, at any x, I have a height called x, where that should match with x, between x and x plus 1. What is the area? Because through with continuous, same what we are seeing, addition of 0 plus 1 plus 2 plus 3 plus 4, that addition will be achieved through gx dx area. The vertical line addition will be achieved through calculating the area. That is integral calculus. I have to find gx. Fx is x. Then what is dx? I don't know what is dx. But one thing I know, fx equal to gx dx. What I am trying to get is fx at x equal to x, that is x. What gx dx from x to x plus 1. Whatever it comes, that should be x. If both are same, you found dx. Okay, let's try now. We'll go with a very high level. Fx is x equal to gx dx. Dx is fx dfx by dx. To come down like this, dx equal to 1. I found dx, that is 1. Try now. 1 dx, x to x plus 1. 1 integration is x to x plus 1. Then it will come as 1. Oh, sorry. We made a mistake now. Okay, what mistake you made? Here it is x, and here we are getting 1. X to x plus 1, x1 dx is x. From x to x plus 1, x plus 1 minus x, that is 1. So that will come as 1. Here it is x, here it is 1. We are missing some. Someone would say, why don't you do one thing? You multiply by x, okay, then it will be same, or add by x. If you add by, you had earlier 1, right? If you add by, try adding by x. So it will be 1 plus x. Try now. Okay, because with 1, you get the end result as 1. Okay, but here end result is x. Okay, if you took 1, then result is 1. Here result is x. You want x, right? Or try with the x itself. Okay, or 1 plus x. Try adding. Okay, 1. Okay, try replacing it with x. Anyone will try. Now let's try x. Here it is x. Try with x only. X dx. X squared by 2. Lower the x, higher is x plus 1. If someone try like this, then x squared by 2, 1 by 2 I can keep outside. X plus 1 whole square minus x. That will be x square, and minus x square will go away. And it will become 1 plus 2x. It will become x plus 1 by 2. Oh, I found it. X plus 1 by 2. Let's try again. X plus 1 by 2. Do the integration. It will become x squared by 2. X squared by 2. X plus 1 by 2. X squared by 2 plus 1 by 2 x. 1 by 2 I can keep outside. X squared plus x. Now place x plus 1 whole square plus x minus x square minus x. X square and plus x both will go away. That's right. What will remain here is 1 plus 2x. That will come at x plus 1 by 2. So we got the result. X plus 1. No. Here it is x. And here you are getting it as x. It is as x plus 1 by 2. Here it is x. Okay. Something like this. Okay. We will work on it. Now try adjusting it. Okay. So that result will become. So it is something like approximation we are trying. What happened this time? We'll try again. X plus 1 whole square, that is x square, plus 1 plus 2x. plus we took as x plus 1 by 2. X plus 1 by 2. If I take x plus 1, 2, what is the difference we are seeing? X plus 1 by 2. X square plus 1 by 2x is the integration. 1 x square by 2 plus 1 by 2x. 1 by 2 I can keep outside. It is x square plus x. From x equal to x plus 1. X plus 1 will give x square plus 1 plus 2x plus x and plus x, and this minus x square minus x. Okay, so my plus x and x square will go away. 1 plus 2x will remain. If I do it again, it will become x plus 1 by 2. Here it is x1. Okay, so what extra we are getting? Extra we are getting 1 by 2. 1 by 2, if I subtract, then it will come as x. Let's try subtracting 1 by 2. Means x minus 1 by 2. Okay, someone can try. X minus 1 by 2. Okay, if I had taken x, then it was x square by 2. X and x plus 1. 1 by 2 I keep outside, then it is x square plus 1 plus 2x. 2x minus minus x square. X minus x square. It becomes 1 plus 2x. It came as 1 by 2 plus x. That's why we took 1 by 2 plus, I think we are on right track. Okay, if I had taken, if people remember, we started with x and this side dx become dfx by fx equal to gx dx is dfx by dx. So it is 1. We started with 1 dx from x to x plus 1. 1 dx integration is x. X to x plus 1 become 1. Here result is 1, here result is x. We'll try with the x because this is what they like. If we try with x, then it becomes x square by 2. 1 by 2 I can keep outside. Limit is x to x plus 1. It's coming as 1 plus 2x by 2. X plus 1 by 2. 1 by 2 is coming extra now. It should have been x, but it is coming. If we put 1, then it is coming 1. If I put x, then it is coming x plus 1 by 2. It should have been x, so that both will be equal. So I have to subtract 1 by 2 to get the x. So we started with the x, that became x plus 1 by 2. Now I'll subtract 1 by 2. So it will become x minus 1 by 2. Now we'll start with x minus 1 by 2. So that at the end it will be x only, because 1 by 2 was extra. So x minus 1 by 2, let us start again. X square by 2 minus 1 by 2. X 1 by 2 I can keep outside. And here it is x square minus x. If I plus x plus 1, then it is x square plus 1 plus 2x. 2x minus x minus 1. And then minus, there we have to place x. More or less, x square term and minus x term, they will go away with the negative. What will remain here is 1 plus 2x and that minus 1. Minus 1, 1 will go away, 2x and outside 1 by 2x. Exactly same. Means we have found Eureka, we have found gx, that is x plus x minus 1 by 2. That is exact equivalent of fx and x. Now if I'm trying to find in summation of 0 to plus 1 plus 2 plus 3 plus 4 plus 5 up to any term, it is same as integration of x minus 1 by 2. Okay, x minus 1 by 2. What is the integration of x minus 1 by 2? Anyone would ask. From x to x plus 1 or whatsoever, x minus 1 by 2. If I do integration of x minus 1 by 2, it will become x square minus 1 by 2x. That will come as 1 by 2 outside, x square minus x. That is x into x minus 1 by 2. Because if I set x to x plus 1, it is coming as x1. That is all right. Okay, means if I have a gx as x minus 1 by 2, it will work exactly well with the discrete function x. Okay, now what is the result? Result is dx is 1 by 2 x into x minus 1. X into x minus 1. Let's try x into x minus 1. If I have to add 1, 0 plus 1 plus 2 plus 3 plus 4, what is x is? X is going from 0 to 4. Okay, through integration, we have got the result as it should be x into x minus 1 by 2. If I substitute x as 4, it is 4 into 3 by 2, that is 6. Let's add it here. It is 4 plus 3 plus 2 plus 1. It will be 10. Means x I have to take other side, means x plus 1. If it is 0 to 4, then x is plus 1. Try with the 5. Now it is x into x minus 1 by 2. Try with the one more, that is 5. 5 into 4 by 2, 10. It is same. Okay. Try with the another thing. Try with the 7. 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7. If it is 7, then 7 plus 6 is 13. 13 plus 5 is 18, and then 10, 28. Let's try here. X into x minus 1 by 2, where x is plus 1, I'm taking 8. 8 minus 8 into 7 by 2, that is 20. Okay, someone would rephrase this rather than saying x into x minus 1 by 2. Let's say make x equal to x plus 1. This is what you are doing. Yeah, this is what I'm doing. X plus 1 into x by 2. Okay, through integral. Then someone would say, what happened to your banking problem? You were boasting about, we will do it. Okay, same manner. We will do. Can we transform our discrete function into integral calculus so that we get the solution? Mind blowing, amazing. Mind blowing, amazing. Okay, mind blowing, amazing in a way that by switching, by doing fx equal to gx dx, x is x to x plus 1, we are getting gx by doing some resettlement, and then it works like charm. So what would be a to the power t minus 1 plus a to the power t minus 2? This is the discrete function, that is a to the power t minus x. What will be exact gx? That will be continuous function, so that if I calculate integral calculus, it will give the result that we will see. This is dividing problem into n different part or t different part, and then sum it and sum the sub area in the integral calculus and go with it. Amazing, mind blowing, hitting head in the wall. We will proceed on this. These are not available in any of the book. Anyone can try. Please don't mind supporting us. +91 is the India country code. 9483160661 is the telephone. +91 is India country code. 9483160661 is the telephone. Okay.